Okay, so I think I thought we were done because we used to have this in its own section, but it doesn't really need to be in its own section. It's just sometimes our cute little triangles share parts. Either they're sharing a side or they're sharing an angle or something fun like that. So if we look at these, we have a couple different sets of triangles. One of them would be ADC. And another ABE. So when it asks us to separate and redraw them, that is a strategy to help your brain when you're doing your proofs. So I'm just going to do my best to draw the pink triangle and the orange triangle separately. Oh, well, it didn't help that I did that. Oh, okay, well, that's fine. Okay, here's the pink one. So that's A, D, E, A, B, and C. Okay, so the side that they share is obviously going to be congruent to itself. We have these marked on our picture as congruent, both are the angle A's. And then we have angle E congruent to angle C. So that is the code and label. So we labeled with the letters, and then we coded. Fun, fun, fun. So the only thing that we added really was this. When they just share a side like that, it's not too hard to see. We're going to write a triangle congruent statement. So we got to make sure our letters go in the same order. If I start with vertex A, I'm going to make sure that I start with A for the second triangle. Okay, which point corresponds to D? D. Okay, and which one corresponds to C? C. All right, which of our shortcuts proves that these are congruent? Yeah. Easy enough, right? So now we have the same picture, but we have different triangles. I think. I haven't really looked that closely yet, but I think they're different. Yeah, we got ABE. And AFC. Okay, do they still share a side? What do they share? An angle. Okay, so let's redraw our triangles. Just do the best you can. Ooh, that was bad. It's kind of good brain exercise. Okay. Oh, big fail. Why is this so hard for me today? Okay, well, that's as good as it's gonna get. Okay, so we know that angle E is still congruent to angle C. label my triangle. Awesome, good job. Okay, I know that angle A is congruent to itself. I didn't give you guys enough information. There's not enough information. Do you guys see it? I need a side. I didn't give you a side. So the problem is that there is nothing restricting the length of these sides. Like if I don't know that point F is exactly right there. Point F could be here. You guys see what I'm doing? Mm-hmm. This angle could still be congruent to that one. You know what I mean? And these are obviously not congruent triangles. They could just be similar. So we know that these are similar, but we actually don't know that they are congruent because I didn't give you a side. So we can't write a congruent statement, but we can do a similarity statement. How about that? All right. So we can say that triangle ABE is similar to triangle AFC. And if you couldn't tell, we're going to have a postulate called angle-angle similarity. Which, now that you see the picture, kind of makes sense. Sorry that it's not congruent, it's just similar. Would you fix that here too? Okay. Well, that was fun. You're shaking your head. Okay, well, maybe not fun. All right, let's look at this one. See, this is what I should have given you. You see how it says that CD is congruent to CB? That's what I should have given you, something like that up there, but I didn't. So sorry. All right. So I can say segment CD is congruent to segment CB. That is given. Okay, and I know that CDA is congruent to CBE. Do you guys see the two triangles that are happening here? Should we redraw them, or do you think you can do it without redrawing? Without? Okay, I am going to highlight them. So if you're like a more visual person and you want some highlighters, I do have highlighters that you can borrow. They're over here. All right, so CDA is my first triangle. And my other one is CBE. Okay. Any ideas? Angle C. Yeah. Angle C is congruent to itself. Which property tells me so? Reflexive property. What? Okay, so this one is congruent to itself. What do you think? What? Do I need that? Yeah, I'm gonna use angle side angle. So I can just make sure I get my congruent statement in the right order. Triangle ACD is congruent to triangle ECB by angle side angle. Easy enough? Okay. Do we need to do number 5 or are we getting it? Are we good? Okay, so here's where we are. Do we have right triangles? Yes. Check. Do we have a pair of congruent hypotenuses? Check. Do I have a pair of congruent legs? Check. So I am allowed to use R. I'm sorry, it just makes me think of a peg leg pirate. It's hypotenuse. Okay, questions? Okay, that one was exciting. All right, take a stab at this guy. Did you guys mark this on your picture? Those are right angles. Okay, so we know that the very tippy top of the roof, can we call this T for top, is equidistant to the gutters on each side. I'll make it orange so you can see it. Okay, do we have enough information to say that the pitch on both sides of the roof is consistent? We do? What am I missing on my picture? The reflexive property. This beam is congruent to itself. So, do I have right triangles? Okay. Which of my shortcuts am I going to be able to use?
Or right triangles, yeah. Or right angles, yeah.
It's hypotenuse leg again. It's just like the last one.
Oh.
Do you see it? Yeah, we can't use angle side side. That's a big no-no. You put that on your proof, you're going straight to the principal's office. I will kick your asymptote out of class so fast. No, I won't kick you out of class, but we will all laugh at you. That seems fair, right? Okay, so we know that, can we call this point B down here? We know that TB is congruent to itself. So we can use hypotenuse leg. Okay, so we're almost done with this. We've now shown that the triangles are congruent. Do you guys remember what pitch is? Do you know what pitch is? It's like slope, but it doesn't matter what the sign is. Like, obviously on this side, you see that the slope would be positive and this side it would be negative, okay? But if we ignore the signs, then we're looking at the pitch. It's just rise over run, but ignoring the signs. Everybody okay with that? Okay, so if we know that these triangles are congruent, then we can say that this side, this last side has to be congruent. And this sort of brings us to our next set of notes, which is to say that once we have our triangles proved congruent, we're allowed to say that their corresponding parts are congruent. So the parts that we didn't have any information about before, after we've shown that the triangles are congruent, we know that those parts are also congruent, the corresponding ones. Okay? So we're going to say, can I call this G and H? So we are going to say that GB is congruent to HB because of corresponding parts of congruent triangles are, I'm hearing a lot of talking. It's confusing to me a little bit. Okay, now to have the same pitch, we're going to have the same rise and the same run and ignore the signs. And now we have that because we know that this side is obviously congruent to itself and these two sides are congruent. Questions? 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 Okay. All right. So, we're just going to keep it moving. We're just going to keep it moving. So, you guys ready for some good news and some bad news? You are going to have to know the phrase corresponding parts of congruent triangles are congruent. That's the bad news. The good news is that you are allowed to abbreviate it. Okay, so we are going to be still using our shortcuts. Side, 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 angle, 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 side, and hypotenuse leg. All of these shortcuts are going to use corresponding parts of triangles to prove those triangles are congruent. Once that job is done, we are allowed to use the theorem corresponding parts of congruent triangles are congruent to say that the other parts of the triangles are also congruent, the parts that we didn't use with the shortcut. Okay? All right, let's look at how that works. All right, so we are given that PR is bisecting angle QPS and angle QRS. This is given. All right, that shoots us over there. How do we know that this is true? Let me make my little... How do I know that those angles are now congruent to each other? Yeah, this is from the definition of the... No, you're close. The angle bisector theorem tells us that... Oh my gosh, I'm going to mess up the picture. the angle bisector theorem is going to tell us that this point and this point, well, this point is equidistant from both of these sides. That's the angle bisector theorem. The fact, so you didn't make up something crazy. That's an actual theorem, but it tells us something different. Okay, so it's just the definition of an angle bisector that tells us that we make baby congruent angles. Baby congruent angles is the definition of an angle bisector. Did I answer your question?
But it's not the theorem.
It is not the theorem. Okay, so what can I deduce using the reflexive property of congruence? Yeah, make sure, do you guys see that it's going to go P, Q, R, and back to P, and then P, so do I have to change the order? Do I need to change the order? Or should I leave it? Oops. You see that it's either going to be PR or RP and it's going to match? Okay. Don't change the order on this one. So P, R is congruent to itself. Okay, now what? Okay, do I have two pairs of congruent angles? Do I know that their included side is congruent? Okay. That sounded like too many letters. It's angle, side, angle. I heard side, angle, and I got a little confused. Okay, so it's angle, side, angle, and then make sure that you get the letters in the right order when you write your congruent statement. So I'm going to say triangle PQR is congruent to triangle PSR. No, yeah, PSR. Okay, so now I'm allowed to say that some of these other parts are congruent. I'm allowed to say that PQ is congruent to PS. Whoop, how do I know that?
Because the triangle working for us, like we try to see.
Yeah, all the corresponding parts have to be congruent. So the abbreviation for that is corresponding parts of congruent triangles are congruent. CPCTC. I can't say the letters in the right order unless I'm actually looking at the letters. I have to, in my head, write out the whole word. Okay, questions? All right, so why is this beneficial? Well, we can use it in problems like these. Okay, so I know that points A and B are on the edges of a ravine. So like part of the distance, you might not be able to stand there, you know, because the edge might have fallen away. But we still want to know the length of AB. Okay, do you see I have a 10 mile and a 10 mile? And a 15 mile and a 15 mile? If only I had a pair of congruent angles somewhere. Oh, I have vertical angles. Okay, now what do I know about my two triangles? Okay, so I have congruent triangles, which allows me, do I need to find you guys new seats? what you're showing me right now is that you need new seats. So if you don't want new seats, show me something else. Okay. I used my given information and my vertical angles theorem. I've shown that the triangles are congruent, so now what do I know that the length of AB is? Yep. So AB is 18 because corresponding parts of congruent triangles are congruent. Easy peasy lemon squeezy. Alright, do you guys want to do number 3? What is it? Where's JK? Yeah, it's 41. Okay. 41 feet. Alright. Can you guys try one of these proofs? Which one looks the worst? You guys want to do the flow proof? Go ahead and try the flow proof. It's got some of the stuff in there for you already. But it didn't go. Okay, so what can we glean from that? What do we know? Oh yeah. XW is congruent to ZW. Okay, now what? Okay. Okay, because that was given to us. What else? All right. Okay, now what? Ooh, I found a mistake. Do you guys see the mistake? Okay, look at this order. What got messed up? It's in a blue bubble. Look at the order. Oh, no, oh my gosh, wow. I really thought for a second it said WY. All right, I'm gonna just, let's move on. Let's move on to the next one. Now what? Did I just not mark this one? Oh yeah, okay. Yeah, this is side, side, side. Okay, now how do we know that those angles are congruent? Yeah, corresponding parts of congruent triangles are congruent.